Professor David Mindell is a professor of aeronautics at MIT and also divisional professor of the history of engineering and manufacture. He co-chaired the task force on work of the future at MIT. Let me end this. Sorry. It's Professor Mindell is a really rare combination with both the engineering background and the humanities background, which I really respect as the precisely what we needed to understand and solve today's mobility problem cross scale and cross mode. He researched on a variety of relationships between people and machine, and he has developed and commercially licensed the spread spectrum sonar technology for undersea navigation. He wrote 6 books, including the most recent one on the work of the future that hopefully Professor Mindell will touch a little bit, as well as the book like Our Robots, Ourselves, Robotics, and the Myth of Autonomy. He's the co-founder and CEO of Humantix Corporation, which is pioneering the micro-location technology to revolutionize how people and machine locate, navigate, and collaborate. I just see, and one more word is, Dave is also a like key supporter and advisor to the mobility initiative and contribute to the initial concept and as well as many of the implementation of the mobility initiative. So I really thank David for joining us today. Last year, I invited him to talk about the micro-location transit, and today I will invite David to talk about the regional air mobility. David, the forum is yours.
Thank you. It's great to be back here, and thanks to Jinha for giving me a whole week to prepare this talk. We had lunch the other day and he said, how about you give the talk on February 18th? And this is not a canned talk. I've never given it before. So it's a lot of new thoughts, but it's of course exciting and interesting to bring something together for the first time. My goals today, let me get my screen share up here. My goals are to introduce the idea of regional air mobility and some of the key players and issues. And it's really, think about it as an introduction, and also to show how it links to some national priorities in the United States right now, such as the work of the future and manufacturing and R&D. And also just to encourage the mobility initiative to think in the third dimension. There's a lot of exciting talks here. And I'm excited for really every single one for the rest of the semester, but nearly all of them are either automotive or surface-based. And I just want to remind everyone by this talk at some level that there are other modes of transport that should be considered, and aviation and aerial mobility is really one of them. And of course, important how it links to the other modes of transportation. So let's not assume that mobility means automobiles. I also am beginning a series of conversations, which will probably end up in a book, about the future of industry. And how do we think about a future of industry in a way that's optimistic and embraces technology, but is also primarily human-centered, not utopian, and looking forward to an equitable and decarbonized future. And that's not actually an easy problem, given the way that we've become used to talking about technology. So you may well have heard of a lot of excitement about UAM, urban aerial mobility. This is just one of many slides from NASA. There was about $7 billion in investment put into this industry last year. There were 5 SPAC IPOs, Blade, Joby, Archer, Vertical. There's another one this year by Eve. And according to a McKinsey study, there were options and orders and letters of intent for about 7,000 aircraft worth almost $30 billion just in 2021. And that outpaces the order volume for conventional aircraft by a factor of 10. Slightly skewed comparison because 2021 was a particularly bad year for commercial aircraft orders, but still lots of enthusiasm, lots of excitement for novel kinds of aircraft that will whisk you away. And in fact, one of the players is even called Whisk, from urban vertiport over the traffic to your home in the suburbs or somewhere else. You, I'm sure, have heard some of the names here. Joby, who's partnered with Uber and Toyota and acquired the entire Uber Elevate operation. Archer has an order from United Airlines, Vertical Aviation, Blade Aviation, Lilium, really interesting space. Also worth pointing out that almost all of the stock prices of these companies are down in the 60 to 70% range since they went public. That may well say more about SPACs than the prospects for urban air mobility. And if you're a believer in it, it's a good time to buy stocks probably, but it reflects a certain amount of market uncertainty. And I understand that uncertainty because UAM really depends on about, I count sort of 7 different revolutions: new airframes, new energy storage, new controls and autonomy, new propulsion and electric motors, new business models, new infrastructure around vertiports, new regulatory regimes, new airspace design, and new air traffic control. And those last 3 are all under the control of the FAA, who's not known for moving quickly and still smarting from the 737 MAX disasters, and I think they're probably not too great at distinguishing the organizational failures there from the technology failures. I'm not going to say more about UAM today, but I am going to talk about a slightly different way to think about this problem, and that's regional air mobility as opposed to urban air mobility. There's a really great report that was done last year by a group at NASA. And actually, Kevin Ancliffe, who led that team, I think is on the call today, as is Maxime Gariel from X-Wing, and there were folks from NASA and Boeing, Reliable Robotics, Magnix, Ampere. And this one quote sort of captures the sense of regional air mobility, focusing on building on existing airport infrastructure to transport people and goods with innovative aircraft over with improved affordability and efficiency over existing options. And multiple technologies do not need to advance simultaneously for RAM to advance. So I think as the authors of this report, and many of the things I'll share in the next few minutes come from this report, it feels like a much more here today type of model. I would highlight also in this quote the notion of community compatible, so low noise, low nuisance, low carbon emissions, transportation mobility technologies to benefit ordinary people. So think about modern aircraft, high utilization enabled by new business and operating models, kind of ride sharing models. And I'll talk later about autonomy and electrification for both logistics, packages, e-commerce. One startup is focusing on organ delivery, and a new passenger experience, including not only how you book transportation multimodally, but also how it's integrated into other transportation modalities. And I think the key starting idea, and really one of the drivers, and this is why having trouble advancing my slide here, a second. When I shared my screen, my mouse disappeared and my keyboard is not. There we are. The key idea is existing airport infrastructure. So you today can buy in the United States a commercial ticket to one of 500 airports in the United States. But that is less than 10% of the commercial airports in the United States. This image is a typical aviation chart of New England. And you can see Boston here and Cape Cod, and you can fly commercially from about 6 of these airports: Hyannis, Nantucket, Martha's Vineyard, Providence, Worcester, and Boston. But there's another 24 airports just in our little southeast corner of New England. Yet 0.6% of US airports support about 70% of domestic travel. So at some level, all we're talking about is making use of infrastructure that we already have that is largely supported by US taxpayers. There's a long history here. The 1946 Federal Airport Act created these 5,000 airports. There were many returning pilots from World War II, a huge increase in the number of trained pilots, many training fields, and the vision was, as way back then, as akin to the early interstate highway system. One of the things that happened was that when jet travel was introduced in the late 50s and matured in the 60s, jets tended to concentrate on larger runways. And, Karl Marx famously said, the hand mill gives you society with the feudal lord, the steam mill gives you society with the industrial capitalist. That's actually not true, because the social relations don't flow necessarily from the technology, but I can parody that by saying the fossil fuel jet engine gives you the hub and spoke system that we all suffer in the airlines today. So one question for regional air mobility is just simply, how will electrification, sustainable fuels, and various forms of autonomy enable change in that system? It's not a technology determinist story, but the technology does open up certain choices for us as researchers, industry, investors, policymakers, that we can choose to take advantage of these systems. There's also parallels in the sort of early 2000s that NASA had a great program called Small Aircraft Transportation System, created these innovative aircraft called very light jets, and there was even concern that the very light jets would darken the skies. That didn't quite happen. This is a Wikipedia page under very light jet, and of the 24 or so projects they list here, only the green ones on the top, there's 4, are actually in production today. It's from Cirrus, Honda, Cessna, and Embraer. They're all good airplanes, but they kind of provide the lower end of the private jet scale. They didn't revolutionize too much. Although a lot of that thinking really does carry forward in today's RAM story. Jim Womack, our friend, who's often, I don't know if he's here today, but has written a lot about lean. And even in this era, Jim was writing about lean transportation options. A lot of his ideas and that writing still really holds up quite well today from RAM. RAM is lean air transportation. It's flexible specialization, it's mass customization, as opposed to the 20th century mass production model that the airlines have given us. And there are many other examples in the past and current day. If you've ever been to Alaska, you'll know that Alaska, pictured here on the left, the red are the many, many public use airports in Alaska, thrives on small aircraft transportation. Over on the right is the route map from Cape Air, still fairly hub and spoke looking, but they serve the Northeast and are largely subsidized by the Essential Air Services program out of the federal government. And unsurprisingly and appropriately, they've placed a major early order from Eviation for an electric aircraft to cover some of these routes. And in the middle, my friend Nat Sims is on today, who's a pioneer in medical devices and also very thoughtful about air transport coming out of northern Vermont. He sent me this schedule from Air Vermont from 1983. So when we talk about regional air mobility, at some level, we're just talking about things that we already have or are already working in some places, scaled in a new way with new technology. Here's a typical trip that I take. I have a small Beechcraft Bonanza. It was designed in 1947 and still manufactured today. And this trip from Hanscom here in Lexington to northern Vermont takes about 35 minutes as opposed to 3 hours driving. It's about double the fuel, so it's not particularly green, but it's very convenient. And once you're in Vermont, you still have access to the entire Northeast from an air mobility point of view. So general aviation pilots have been doing this for a long time. And let's be clear, we have a system like this today. We have a complete private elite air transportation system based on this publicly funded infrastructure in the form of private jet air travel and other types of aircraft. The public image of it is pampered people with sunglasses, and some of that is certainly true. But most of it is supported by business, and business supports these aircraft because they pay, and there is value to mobility at this higher level. And partly, again, the vision for regional air mobility is to democratize access to this system and make this type of mobility greener and less expensive and accessible to more people. So looking at car trips, this is an image from industry. If you're traveling in an urban setting, you have many options. And we, of course, know that with this group: bicycles, rideshare, trains, buses. But when you're in the medium range, say 50 to 500 miles, it's almost only car trips. There are 3.5 billion car trips in this range area every year in the United States, over 1 trillion passenger miles. And I don't think anyone expects aviation to take over all of those trips, but even a small fraction is a viable industry that can also really make a difference. On the cargo side, if I send a package from Boston to Rochester, New York, where I happen to be from, that package will go through St. Louis or Memphis on its way. It'll go on probably 3 aircraft, 2 trucks, 6 hands-off, over 1,000 miles, and significant carbon emissions associated with that. And of course, the world of e-commerce and kind of atomized distribution is very amenable to thinking about some of these models. Many e-commerce providers would like to provide you a green option for green delivery from their warehouses. The technology for that really doesn't exist today. So a few of the players, and there's many players here, but I'll pick a couple of them. On the top left is the Eviation Alice, a company, really interesting company doing electric aircraft. I mentioned them as ordered by Cape Air. They're in the Pacific Northwest. On the right is from Electro.Aero, a blown wing hybrid electric aircraft. Electro.Aero is founded by MIT graduate John Langford, who had started Aurora Flight Sciences, and many of my colleagues, Mark Drela and John Hansman from AeroAstro, are involved with them. They're based out of Virginia. The bottom left is really cool company. So the aircraft is called Alia. It's a mixed eVTOL from a company called Beta in Burlington, Vermont. And they've been progressing at an amazing pace lately. They're the ones I mentioned who are starting with organ delivery as their model. They're also building VTOL and charging infrastructure. Really interesting and exciting to see such a innovative company in Burlington, Vermont, which is not a place usually associated with innovations in aerospace. And again, part of the value of regional air is we can begin to stimulate some of those areas. And the bottom right from X-Wing, I think Maxime Gariel, the CTO, is on today. X-Wing was founded by him and Mark Petit, from both of them MIT graduates. They're located in Northern California, and they're focusing on autonomy for regional cargo delivery. This is the Cessna 208 Caravan. It was actually designed by FedEx with Cessna, and covers many of the feeder routes that bring packages to the larger hubs. As you can see, none of these 4 companies, and this is only 4 of maybe a dozen, are actually approaching the problem in the same way. And I think that's exciting. There's a lot of different thinking about it. There's no monolithic model. It hasn't really converged yet in that way, but there's a lot of great innovative work going on. Another one of those companies is Lilium, also has gotten a lot of attention. But just picture this as one form of the vision. Lilium builds this electric kind of, well, they will build an electric 7-seat jet. On the left is a route map that they've proposed for Northern California. On the bottom right is an image from the NASA RAM report that I mentioned earlier about the just the number of airports in this country. And what does a world look like where we can affordably fly with a low carbon footprint to or from many of these airports with an on-demand model? I think there's two real key enabling technologies here. One of them is electrification. Um, Electric motors are very efficient compared to fossil fuel motors, and obviously they have reduced emissions, reduced noise, reduced maintenance, ultimately reduced cost, although there are real challenges associated with the energy density of batteries. I put these two images up here just to show that Airbus is working heavily on this technology, as is Rolls-Royce and a number of the other big players. This image on the right shows you a great image of an electric powertrain for an aircraft that broke the world speed record last fall for an electric aircraft. You can see the batteries, a kind of black unit up in the nose with the power converter and thermal control. The actual motor is only the little silver cylinder behind the propeller. But batteries are 40 to 60 times less power dense than jet fuel. And we're not going to see airliners the way we think of them powered by batteries, I think, any time in my professional lifetime, even with nice generous assumptions of 8% improvement for the year. So electric aircraft will be regional for the foreseeable future. And regional air mobility provides a wonderful place for electric aircraft to mature. There's also, and some of this is mentioned in the NASA report, some side benefits to electric aircraft in a regional setting. As sites for electric power consumption, airports can drive new investment decisions about generation and distribution and charging. Many airports are already reconceptualizing themselves as sites for solar farms. They tend to be public use areas with lots of open space that aren't usable for other things. There are 146 airports in the country with renewable energy projects going. The largest is at Indianapolis International Airport, which produces more than 30 million kilowatt hours per year. Second key enabling technology is autonomy. And for autonomy, you don't necessarily need to think only an aircraft that flies by itself. I do think that an imaginable end game in 3 to 5 years is an electric aircraft where you push a button and it will move safely from one place to another. But there are a lot of steps along that way, including reduced crew from 2 to 1 pilots, simplified vehicle operations, which enable reduced cost for certifications and duty days. And many of these options afford improvements in schedule flexibility and routing, where you don't have to return a pilot home every night, or you're not limited by a 6 or 10-hour duty day. Obviously, the aviation, the autonomy problem is aided somewhat by the automotive industry and all the work going in there, although autonomy is proven in aircraft now for decades in the military realm and elsewhere. And many of the major technical problems have been solved, and now we're facing certification problems. The FAA hasn't quite figured out how to handle it right, except for, I will point out, and I put this up, Garmin Emergency Autoland. This is a technology that is certified, that you can buy today. It won the Collier Trophy last year. It's the highest award for aviation innovation. And in a couple of aircraft, including the Cirrus jet up on the upper right, if the pilot is incapacitated, a passenger or the pilot can push one button, the aircraft will declare an emergency. It will find the nearest suitable airport, plan a landing and land automatically. So that's an emergency certification. A lot of the rules are easier for emergencies, but it is a kind of foot in the door, camel's nose under the tent for autonomy in more normal operations. So to close, I want to talk about beyond the technology, which of course at MIT we can talk about all day, but let's think about how RAM fits into larger priorities. I'm a big fan of Lewis Mumford, who was one of the founding thinkers in the field of the history of technology, and Mumford was a regionalist. In his classic book in 1934, very much inspired by early aviation, He says, just as every region has a potential balance of animal life and vegetation, it has a potential social balance between industry and agriculture, between cities and farms, between built-up spaces and open spaces. Bill Cronin's book, I put it up here as well, Nature's Metropolis, does a beautiful job of explaining the interdependent relationships between cities and countries. And there's a strong current of regional thinking in technology and obviously in urban studies and planning. City and country need each other. The United States right now will benefit by building closer social and economic ties between rural and urban areas. And as I mentioned in my work on the subway system when I gave a talk here a year and a half ago, getting people from lower income, lower cost of living areas into higher income, higher paying areas and getting them home again where they can live affordably is a valuable goal for much of our technology and business. And I should hasten to add that I don't think that all of the value of regional air mobility has to do with city to country or urban to rural transit. I think regional to regional, intra-regional is quite important as well. Jinhua mentioned the book that David Autor and Liz Reynolds and I just published based on the work of many people at MIT on the work of the future. And of course, remote work is now a thing. I don't need to go too far into this because I'm sure you're all familiar with it, but to revitalize work in this country, we need to revitalize the US industrial base, very heavily regionally oriented. We want to share prosperity beyond the coastal cities, and labor markets tend to be very regionally focused. And finally, and I put this slide here, Jinhua pointed me to the work of his colleague, Jose Barrero. I think the website is WFH.com, where they have an amazing amount of survey data and valuable tracking data and thinking about what remote work will look like. I work with a chip designer at my company who lives in northern Vermont on a farm with his family. Rural broadband is an issue that is actually kind of the flip side issue of rural mobility. But once we got him broadband up there, he's able to design chips and then come down to our office in Waltham maybe 3 or 4 days a month when we need hands-on work. That's a sustainable, supportable work lifestyle for him. And I think many others have been rethinking their mix of urban and regional presence enabled by different ways of working in the office. One of the other recommendations from our Work of the Future project, built on the work of other MIT colleagues of our, Simon Johnson and Jonathan Gruber, their book from a couple of years ago, before the pandemic, but it's still remarkably resonant, about Jumpstarting America, about how US investment in R&D has, first of all, it's declined. That's been a problem. But it's also exacerbated a growing regional imbalance. We can all think of the successful innovation hubs in Boston and Austin and Seattle and Silicon Valley. But Gruber and Johnson really articulate ways to think about bringing similar dynamics and similar positive feedback loops to more regionally based cities. And they actually have a great website based on the book where you can go look at their data and run different scenarios on it. And number one in their suggested potential innovation hubs happens to be Rochester, New York, where, as I mentioned, I grew up. So I went and I looked up Rochester, New York's air connections, and the only place that you can get to are these hub and spoke: Boston, New York, Detroit, Philly, Chicago. You can't go from Rochester, New York to Columbus, Ohio. You can't fly from Rochester, New York to Burlington, Vermont without a connection. And as we think about revitalizing manufacturing in this country, Suzanne Berger's work has shown us that one of the great problems with small and medium-sized manufacturers has been they're not beautifully well connected into their own regional networks. There are a number of ways to solve this, but moving people and moving goods conveniently and quickly at regional scales should certainly be one of them. And then you add to that, of course, revitalizing the aerospace supply chain. Who's going to make all the pieces and the composite parts for all of these exciting new startups? And there's just a tremendous amount of opportunity for the aviation infrastructure in this country to contribute to the revitalization of US industry. So I'll close there and open it up for conversation, really by saying, I think the vision for regional air mobility is still gelling. As I mentioned, there's a lot of different players doing a lot of exciting different things, but the pieces are increasingly there, and a concerted push can really tie it together and push it through. Questions remain about the path for electrification, how quickly these new vehicles can get certified and up to speed, how do we maintain the safety that we expect from both air and surface communication. You may have noticed the FAA administrator resigned yesterday. I think it's really important they find a new administrator who understands autonomy and safety and these new technologies, although I'm not too hopeful about that. And it's just a really exciting moment where technology is changing very rapidly. How we work and how we manufacture and how we move things around is changing really quickly. And there's just a lot of opportunity for thinking, again, about the future of industry in ways that are innovative, human first, decarbonizing, but not utopian and pragmatic. So let's return our eyes to the ground and get to work.